Hi everyone, my name is Ashila Putri Anjani Barli, and in this session, we're gonna prove a theorem of geometry which say the length of a median in trapezoid is 1/2 the sum of the two bases. But wait, do you know what is a trapezoid actually? Do you know what is the median or the base? So before we jump in, we're gonna recall that for a second. Trapezoid is actually this. This figure is a quadrilateral that have one pair of parallel sides, and the other side will be called as the length. Next, what is the median? If we have the trapezoid of ABCD and we have E as the midpoint of AD and we have G as the midpoint of BC, when we connect the midpoints of those, EG will become the median. So the median is actually a segment that connected the midpoint between the two legs in trapezoid. And what is the basis? The basis is the previously that I called the parallel sides. Yes, the AB and BC is the basis. So we're gonna prove that EG is a half of the sum of AB and DC. How we're gonna prove it? Take a look at this trapezoid. In this trapezoid, I want to make an imaginary line. So the imaginary line will lies from D to B. This is called the diagonal. The diagonal will part the trapezoid into two parts of triangles. Yes, the triangle BCD and triangles ABD. First of all, I want you to be focused to the triangle BCD. So, in triangle BCD, we also have the segment of FG, right? The F and G. But if we take a look at this triangle is actually consists of two triangles. Yes, it is the FBG and the DBC. These two triangles actually have one angles in common, which is the FBG angle and the DBC angle. Yes, it was called the identity, which will make the angle congruent to each other. So there is also a theorem that said the median of a trapezoid is parallel to each basis. So actually in here, FG will be parallel to DC. Okay, so if we take a look at this figure, we will be reminded of two parallel lines that cut by a transversal. The two parallel lines is the FG and DC, and the transversal is BC. Do you know where's the corresponding part of these parallel lines? Yes, the angle FGB and the DCB is actually corresponding to each other. So if we know that it is a corresponding angle, we will also know that it is congruent to each other. So if we take a look at it again, it actually have one more side which is parallel and transversal. It is the line FG that parallel to BC that cut by the transversal B. So the same concept of corresponding angle will be applied, which is to the angle GFB and angle CDB, right? It will be congruent to each other. So we already have three angles that congruent to each other of the triangle BGF and the triangle BCD, right? What do we call by this concept? It's actually the AAA postulate. So when we already know the AAA postulate is applied to these two triangles, we will also know that these two triangles is actually similar to each other. So what they said by the similar triangle? Yes, the side of similar triangle will be proportional to each other. So if we have BG equals to 1/2 of the BC, as we know that the midpoint is applied to it, we will also know that FG is actually a half of DC, right? So this equation is actually what we need at the end of the session. So we will save it, okay? Next, I want want you to be focused on the second triangle, which is ABD. In this triangle, we will also have two triangles because it is cut by EF segment, right? So we will have the triangle DAB and the triangle DEF. We will also know that EF is parallel to AB because EF is part of median, and the median will be parallel to the bases, and AB is one of the bases, right? So it is parallel to each other. We also know that it is two parallel lines cut by transversal. There's actually two transversal, the AE and the BD. The transversal AB will have the corresponding part DEF angle and DAB angle. Yes, those two angles will be congruent to each other. And the transversal BD will produce the angle EFD and angle ABD congruent to each other because it is also a corresponding part. Right? In these triangles, we have three congruent angles, which will fulfill the postulate of A, and A for similar triangle. Same as the similar triangle before, this triangle will also have proportional sides. Yes, when ED equals a half of AD, so that EF will also equal to a half of AB. So EF will also be equal to a half of AB, right? So this is the second equation that we need to look for the midpoint. So the first equation, we have FG equals to a half of DC. And the second equation, we have EF equals to a half of AB. Now take a look at the midpoint. This midpoint, what does it consist of? Yes, it is consist of the line EF and the line FG. So the line EF, we can substitute it with a half of AB. From the last calculation, we also can substitute the line FG with a half DC from the last substitution. So line EG will be equals to a half AB plus a half DC. After this, we will apply the distribution properties to the equation, which will produce EG equals to a half of AB and DC. Now take a look at this equation. EG is the median, right? And AB and DC is the two bases. Now, from this equation, we know that the median is equal to a half of the sum of the two bases because we have the AB and the DC. So here is it, that the theorem that we have in the beginning is actually proven by this step. If you have any question, please feel free to leave it up at the comment below. Don't forget to like, comment, and subscribe. Thank you. Bye-bye.